Good afternoon. My name is Martin from Telesoft. Thanks for joining one of our whiteboard sessions. We're going to be talking today about security operations when we get to the terabits per second scale. And part of this discussion is to talk about the technicalities of that. There are other parts which form the bigger picture. There are elements around legislation, potentially, sovereignty, affecting real-time strategies, and what we can do for the future as well in terms of what's happening beyond what we can see currently. So we're going to go straight into it, and we'll have a look at what the fundamental high-level problem is, which is that visibility decreases with scale. As you go up in rate, your visibility decreases, and we don't just mean in terms of traffic, in terms of having to look at every packet on the network amongst those billions and billions of packets, and then forming those into, metadata for analysis for machine learning or artificial intelligence, looking for signatures and malware and that sort of thing. We're also talking in terms of scale and visibility is, in order for a network or in order for an organisation to reach the scale of terabits per second, it must have undergone a significant amount of growth. So potentially mergers and acquisitions or just organic growth. And with that comes a certain number of challenges, because the people who administer the network and security operations don't have the full visibility of pieces of their organisation that have been joined together. Another aspect which needs to be considered is the impact of legislation and sovereignty as organisations or as networks grow. If they grow beyond a single sovereign boundary or beyond a single political boundary, you end up with having to adhere to certain pieces of legislation relevant to the countries which are the parts of the network are operating in. So that's one element of the visibility that it reduces. Another element is that the alerts, the quantity of alerts, the scale of the alerts, and the attack surface, which grows with the network, but the number of alerts which grow with that scale of traffic is just mind-bending. It is absolutely incredible. You're talking having to handle, an exorbitant amount of indicators of compromise or actual attacks or behaviours and APTs, all these different things. And how do you triage and action those so that you can effect a kind of strong security posture? And effectively what you lose is actionable intelligence, or the visibility of actionable intelligence, as the rate increases. So that's quite a big hurdle to overcome. Another aspect of security operations terabits per second, as we say, is it crosses boundaries. So as I mentioned previously, it crosses legislation boundaries. If you're moving from, if you've got like a multi-country setup like you do here, then you'll have issues with visibility in certain types of legislation that allow you to see certain things in certain countries. You can't necessarily join the dots. Sovereignty of data comes into effect where you can't move the data around as you would, but you have to effect your security operations at that time. The other aspect of boundaries is technical boundaries. So what you end up with is a network with terabits per second. It has so many different types of technology in it. And broadly, they're sort of, kind of physical. So in our diagram here, we've got data centers, we have edge computing, we have cloud, we have network function virtualization, like virtualized networks. We have IT networks and operational technology networks, kind of things that use industrial control systems, that sort of things. If you're, depending on if you're in manufacturing or power utilities, even elements of banking, that sort of thing. So as the network increases its scale to terabits per second, it has more complexity about it. And as you can see, there are other types of networks and technologies which get brought into this. So high-performance computing and supercomputers, you're likely to start having pieces of these depending on your industry. You potentially going to have like 5G, IoT technologies, these style of things, these types of things. When you're dealing with large amounts of data, like for smart cities, if you're putting together smart city infrastructure. And all of these things form a picture of a terabits per second network, which you have to protect. That's sort of the visibility side So the impact of the technology, or the aspects of the technology and the skills that go along with that, is that the tools don't tend to operate at, off-the-shelf tools don't tend to operate at terabits per second. It's fairly simple. You start needing quite specific tooling to operate at that kind of scale. Simply put, you can't just sort of download a piece of open source software, typically, download a piece of open source software and then expect it to work at terabits per second, at billions and billions of packets per second, at millions and trillions of events per second, and start looking at it scaling out into, I think we're quadrillions and things for as we go through. Quadrillions of pieces of information which you'll then start to look through. And that scale is quite something. And you need the tools which are going to enable you to see the events and make computer-oriented decisions and provide actionable intelligence for humans to make human decisions to, again, affect a strong security posture. And as the rate increases, the tooling decreases, the visibility decreases, and you need a slightly different type of analyst and security operations and strategy when you're dealing at these rates, because they're unique problems as you go through the rates, mostly down to the volumes. Lastly, in terms of sort of security operations at terabits per second at a high level, what you're looking at is you are likely to be either direct or collateral damage within the global cyber warfare scenario, within global cyber warfare. So you're either a target if you're a large organisation providing some sort of infrastructure for a country, some banking, finance, aviation, whatever it is. You're at that scale, you're likely to be either a target, or you could be a cloud services provider or cloud provider. You're likely to either be a direct target, or cyber warfare, if you're like a communications provider, is played out on your network. So you are actually porting nation states or criminality attacks on your network. And as a result of that, you are also kind of a target and you're collateral damage at the same time. And that brings with it unique issues to try and resolve and to affect a strong security posture so you can protect your own digital assets, your own commercial imperative, and your own interest. So that's the high level. Now, I'll just describe briefly what's going on in the middle here. And this is just a diagram of a huge network with lots and lots of different component parts to it. And I'll dip in and out of that and highlight certain pieces of the technology and of the infrastructure which are relevant to the different parts of the conversation. So thing one was the overview of security operations at terabits per second. Okay, now we have to get on to the kind of strategic side of things. So the strategy, how do you effect a real-time security strategy at terabits per second, bearing in mind the various challenges and issues. So in order to understand what your strategy, or what's good for your strategy, you have to understand what you're facing. And really, you're facing two different groups, criminality and advanced persistent threats. And they have got normally it's one of three aims. You broadly describe it one of three aims. Sabotage, espionage, theft. Whether it's in whichever arena, whichever environment it is, sabotage, espionage and theft. And that's what you're fighting against criminality and advanced persistent threats. Now, in terms of your strategy of how you deal with that, there are two time frames which you look at. So the first time frame is in real time. So something happens now and we affect a mitigating strategy, or we acknowledge it, or we can see it and we can respond to it. And we can do that in real time, as in it's a DDoS attack and we want to stop it. It's a piece of malware and we've got kind of something to like a signature matched intrusion protection system, firewall, and it blocks that. Or it's an insider threat and we've got network access controls to block people from misuse of the data or transitioning between different parts of the network to try and stop them from stealing customer data or sensitive information or valuable information. The other part of the puzzle, the other timescale which you deal with, exhibits in forensic operations, at which point time is of the essence, but not in real time, but then quality of and accuracy in your availability of information within the investigation, the forensics investigation, becomes utterly key. So you need to be able to move from high to low, from an alert to the packet level, or to the event level in the network, or the application, or the certain part of the network. And you have to piece all these things together and have something which you can actually work your way through and understand. So these are the sort of two main timescales which you're dealing with. The third thing is what is it that you're protecting? So he said who's attacking, how, you know, kind of what your timescales are to deal with that, but what are you actually defending? And it's easy to say that you defend commercial imperative because it's a nicely nebulous phrase which, you know, kind of people you understand the gist of it, but the reality is if you're an organisation which has got a terabits per second network, you probably don't know, your security operations, your network operations probably don't know all of the parts of the network. So actually you end up in a position where your strategy has to protect both known and unknown network assets. It might be a piece of video production infrastructure and a kind of part of an organisation which you've acquired. It could be, you know, kind of like a new rollout of the cloud infrastructure where you've got a test environment, or it could be a, you know, kind of piece of production infrastructure which is out and about, but it has not been brought back when it's been rescinded from production use and it's been left there, and that forms another sort of entry point into your organisation. So you're actually having to protect both known and unknown network assets, and that's quite a difficult thing to overcome. So your strategy needs to encompass those key three things: who you're fighting, what timescales you've got to deal with the various different types of threats, and what you need to affect. So either real-time response or an in-depth forensic analysis. And also, you need to know that there are known unknowns. You need to find out what it is you need to protect, or at least you need to have provision in place to protect things that you don't necessarily know that are under your control and within your kind of digital estate. So, if we go on from here, any organisation which is in terabits per second will either have a kind of like a highly distributed, you know, kind of large, multi-country, multinational operation, or these things may be sort of, you know, shrunk into a single country or a single geographic boundary. And it will contain various things. So we've got like rings of data centres, as I say, high performance of supercomputing down here, got elements of 5G, and we've got kind of local networks like office headquarters or regional office networks. And then pieces of legislation which affect those particular areas. Now, in a case of a distributed network, like a geographically distributed network, you run into two very considerable adherences, so requirements of your operations. So one of them is sovereignty, and another one is the legislation which kind of goes along with sovereignty. And in terms of sovereignty, we talk about sovereignty as anything which belongs to, or anything which legally belongs to a nation state, or exists within a nation state's boundaries. And that includes, you know, kind of the data, the people, the things, whatever the nation state is protecting. That's a good way of putting it. Whatever the nation state is protecting. And security operations at this scale, if you're going cross-country, means that you have to have security operations which cross those sovereign and legal, political, economic boundaries, which forms quite a complex picture. So in terms of the legislation normally affects what you can see, what you can do, what you can store, what you can't store, what you have to protect. And that kind of, you know, you start getting into kind of like data sovereignty. So at a data level, because it's easy to split these things out. So at a data level, you're talking about, you know, things like GDPR, or you know, kind of where we have to protect the data as it's being held. But that only exists in, you know, kind of states which are adherent to GDPR. But there are other forms of GDPR elsewhere, such as in the States and wider afield. And depending on if you've got operations in the States and in Europe, then you would have to adhere to GDPR and understand the data movement through the system. And that's quite critical. A good example would be personally identifiable information within within Germany, you know, kind of within the German sphere of the German sort of estate, or the German within Germany. You have to factor that into both GDPR and wider afield in your operations and where you're storing the data from these different locations. Also, there are compliance reasons why you'd want to do this, like internal, which are normally driven, like policy-wise, which are driven by the legislation or the regional legislation, but then filter further down. And these all have a big impact as you go through. The next type of legislation is what you broad term, you'd call it endpoint legislation. So things like the emergent IoT legislation, which is designed to protect actual devices and stop, or you know, kind of just to protect the actual endpoint device. It's not really about the person like GDPR is. It's more and the data. It's more about the actual endpoint itself. And within there, you also have, you know, kind of. Within that sphere, you also have emerging technology to across the world to try and restrict and to try and protect access to things like, as I say, our IoT devices which use smart cities, and also kind of handsets, you know, kind of security software to protect user phones, all these different things, and really, in amongst all of this sort of morass of legislation and security operations, it's really difficult because everything's moving so fast. And you have to be able to look at all of this, understand which data you can use and where, join it all together, decide either via machine or human as to, you know, kind of what indicators you've got from what you can see are actually going to be a threat, triage it, and affect a response. Which means you still need a single view. Regardless of where that data is stored, how it's being stored, how you can move it around. You need to find a way to give it a view, because that's your business operations. And that's a really challenging thing to do. And in order to do that, what you fundamentally need to do is you need to have a distributed system which can sit and adhere to the relevant local pieces of legislation and local policies within that sovereign estate, and be able to join them up in a coherent way for effective security operations. So you can see if, you know, kind of a device has been compromised here and it's coming through to one of your data centers in a foreign country through some sort of tunneling, or you've got you know, kind of people are trying to move data, or you know, commit the classic espionage, sabotage, and theft. You know, that's what you're looking for, and it can come through any which way. And as we said right at the very start, the bigger the network, the bigger the attack surface, the more collateral damage, the more you have to deal with. So you have to be watching everything as accurately as possible and as effectively as possible to try and affect your security posture. So, the next thing of a single point of operations is not just that you have to adhere to these things, but you need to, within a boundary, within a realm, you need to have really strong sort of access control. And we talk about user role access control, network access control, you know, kind of data access control. And you need to have the infrastructure in place and the tooling in place so that you can actually split these different things out. So a good example would be the guys who are in the data centers in this country should only see the data from this country. So the guys who are, or your security teams that are looking across this need to be able to understand if there's any kind of localized relationship which they need to be aware of, and that would be a kind of commercial relationship, maybe between your 5G provider and one of your operational technologies. If you've got something like, you know, kind of using 5G, a good example would be agriculture or something like that, where what you've got is you've got IoT devices in the field, but you should only be using a single supplier or a single peering network for your 5G connectivity. And if things start going awry, then you need to know about that. So there are kind of single, there are pieces of information which are specific, which are needed to be able to join the picture and understand, you know, if something is a threat or if it's not a threat. And that all follows down through sort of role and data access, because you don't want every security operations member of your security operations team understanding every part of your business. It's easy. It's much cleaner to give them actionable intelligence, i.e. not swamp them with too much information. And obviously that means that the sites then meet their local rules and you can have distributed teams. So that kind of covers like some of the sovereignty and legislation aspects of it, which is quite complicated. And at any point in this, just if you ping over any questions to our Telesoft Technologies feed, I'll just have a quick look over here. I've got a question here which is, has Telesoft Data Analytics capability successfully identified any APTs in the world? Sorry, I couldn't quite see, that's quite a dark screen. So has Telesoft Data Analytics capability successfully identified any APTs in the world? The answer to that is yes, continually. The collateral damage, which I referred to earlier, that happens constantly. We are in the middle of an explosive cyber war between nation states, between criminality, hacktivists, everybody that's involved with this. And yes, this is something which you have to acknowledge and respond to. It is no good pushing this away or closing your eyes to it or even flagging it up and making it a fearmonger. It is simply just data moving around the world. And data moving around the world, it doesn't matter who it is, but if you've got APTs, you know that you can see the data moving and you can understand the data moving, then you can determine if it's an APT or if it's an internal threat or if it's a criminal threat, and you can start breaking these things apart and actually actioning them according to the way in which each one of those different activities needs to be responded to. So the answer to that is yes, continuing. Thank you for the question, good question. So, okay, we've covered what the challenges are. The elements of strategy which we need to be considering, some of the considerations of sovereignty and legislation. But what does the future look like? Because this is sort of, one of those things where it's a flood of information which is coming through. So, fundamentally, I like to say things like, take back the playing field. So if you have a terabits per second network, somebody else is playing this game on your playing field, and you need to take it back. So you have an advantage historically in any kind of game where you have an aggressor and a defender, whether it's poker, backgammon, even tennis. Whomever is the aggressor normally has the advantage. What we're trying to do is we're trying to say things like, well, if we can determine what the attacker 3-year roadmap or 1-year technology roadmap is, then we can acknowledge and understand what potential capability they have, technically, what capability they will have in 1 to 3 years. And we can do that through things like innovation, technical collaboration, intelligence sharing, all these different things. But fundamentally, if we drive that innovation and we denote where the playing field will be, at that point in time, we will have taken back the playing field and we will have the advantage. This game is being played on your playing field, take it back. The other aspect of this, in terms of the future-proofing, or another aspect of this, is understanding that there is specialist tools which are going to be needed both now and for the future. And if you break it down into its smallest possible level from our perspective, my perspective, you end up with legislation and photons, legislation and photons and light on a cable. Because it doesn't matter then whether it's an AI algorithm, a service in the cloud, a IoT device in a 5G supported smart city, high performance computing, anything, so business operations, all of these things, operational technology, all of these things are just data moving in a specific way. Now, if you can determine who should be passing that data between them and how that data is passed, everything will flow from there, and it works out from the bottom up. All of this is data in motion, photons down cables. I know that's an overly simplistic look, but it is the rules of the game. And by the game, I mean it's the game of networking. Now, when you lay legislation on top of that, you can join the high and the low very, very quickly. And that makes a much stronger, simplified picture going forward. So you're looking at tooling for data movement and response. So what is the data movement? What does it mean? Is it the right kind of data movement? Okay, great. We can actually respond to that. And of course, data, fundamentally, data at rest costs you money. It's, hard disks and memory and things like that. But data in motion, it's actually revenue generating for a business. So it's in your interest to, as a commercial organisation, to keep that data moving. So one of the aspects of this then in the future proofing is if we know where, or we believe we know where the technology will be through technical collaboration and through innovation and working closely with intelligence sharing and understand the patterns of behaviour. So if we can understand that, where the playing field will be, then we can test for that now. We can look at actually testing and simulating those environments, both for our tools which are available, to see if they will stand up. Our current tools, will they stand up? Will our teams, are they suitably trained? Do they have the right skill sets? Do they have all of the right elements which they need to affect a problem? And because they're fundamentally the human firewall in all this, and they are absolutely critical. The human firewall being the one of the strongest elements that can permeate throughout an organisation. You know, kind of from people checking that, you know, kind of nobody's doing something that they shouldn't do on their computer, in terms of ensuring that everybody has the right access, and you know, kind of you know, there's no shared accounts, all these sorts of different things, so that you get your network access control, all the way through to humans making decisions in security operations centres to affect the strategy on the front line. All of these different parts are part of the same human firewall. But you can simulate what the future will look like and test for it now, and see how your tools and your team stand up. But also your suppliers. So test your suppliers, because you want to bring those to task if you don't feel you've got that relationship with them. But then also you want to be able to feed back and have this layer of technical collaboration, so they can start developing stuff in line with your future and in line with your future strategy. But all of this is about taking back the playing field, because by doing all of these different things, you can denote what the playing field looks like going forward. So, security operations at terabits per second. It's big. It's very, very, very complex picture. It's ever growing. It's a sort of inevitability that we're going at into that sort of that scale of business as small and medium-sized business become larger businesses, and larger businesses become sort of supersized. And then we have to have the right tools and the right and adhere to the relevant legislation. But we need the right tools. If we can't see it, we can't stop it. And that's really our whiteboard session, I think. I'll just have a quick look. Thank you to everybody who's joined in and been watching this. I think we're going to put out a slide deck of just covering some of the notes which we've covered today, and that will be made available through our digital boundary and our digital estate. So that will be on our sort of social media, it will be on our website, that side of things. So please join in to Telesoft Tech. If you've got any questions following this that you wanted to ping through, please do send them through. We can see or if you've got any suggestions for any future whiteboard sessions which you'd like to see, then give us a shout. Also, one last thing, I have to do a pitch, that if you'd like a technology demonstration of how we, as a company, actually do solve this problem, and we have a series of products and capability which do run at multi-terabits per second and allow all of these different things, then if you get in contact with us again, you know, kind of through our social media, through probably messaging on our social media, or through our website, or give us a ring with our contact details. We have offices throughout the world or throughout the globe. In order to be able to get a technology demonstration to you, you can have an evaluation or a review of it. So give us a shout and we can show you a bit more in detail how we do this. So thanks very much for tuning in, and I look forward to seeing you next time.